In this presentation, we are going to discuss our proprietary communication intelligence software, focusing specifically on its handling of emojis. We have processed the provided datasets and will be using them to demonstrate the various ways in which our software can overcome common issues and provide greater insight into the data itself. The software is part of a suite of processing tools run on our end to generate a load file that is either hosted in our environment or delivered to the client for hosting in theirs. Its most common usage is in the automatic processing of mobile, chat, and social media data. However, because of its flexible, modular design, the underlying technology can be harnessed in a variety of creative ways. One of the fundamental difficulties that arises when working with emojis in an e-discovery context is that they occupy a somewhat gray area between text and graphics. We can easily view them on our phone and send them to others, but it isn't clear what exactly they are or how they should be approached in a typical review. Fortunately, some guidance is provided in the form of the Unicode Consortium. This organization maintains an up-to-date and detailed database of all emojis. It also establishes how emojis are fit within a piece of text, unsurprisingly, as Unicode characters. All characters, letters, numbers, and punctuation are identified by an underlying numerical code, and emojis are no different. However, while this is a valuable insight, it is of limited practical value. These Unicode characters are still distinct from the normal words and numbers that we typically encounter. And, as the above image demonstrates, they can be rendered in wildly inconsistent ways. The issue is that while the emojis themselves are keyed to Unicode characters, this still does not establish how those characters should be displayed on a given piece of software or operating system. Fortunately, communication intelligence provides a highly effective and simple way to address these issues, as it is most frequently used in chat and mobile data, so let's begin with that. When working with chat data, we are responsible for generating the documents themselves. During this process, emojis come into play at two stages: the generation of the native file, where they are displayed graphically, and the generation of extracted text, where they must be represented textually. The above demonstrates how two snippets of the provided chat data appear as rendered through the software. The document itself is a standard PDF file, and crucially, the emojis themselves are embedded images that are pulled directly from the generic images listed in the Unicode Consortium's database. Right away, this provides a major advantage. Unlike other systems which rely on the underlying system to render the emojis and risk being displayed inconsistently across different machines, these will always look the same regardless of operating system or software. Where things get more interesting is in the generation of extracted text. This is crucial because we rely on extracted text to index and search documents. Thus, by referencing an internal emoji dictionary based on the Unicode standards, we render emojis to single token textual descriptors based on their name. This has many advantages. It provides a concise description of a given emoji that can help clarify its meaning. In addition, these are now indexed and can be searched like any other text. While mobile and chat data are the most popular candidates for this technology, it is not limited to any one data type. As seen above, we have also processed the various email sets that were provided. Since this data is processed based on the underlying document, we do not alter the native or the generated extracted text unless that is desired. Instead, we commonly provide a text overlay containing the labeled emojis, which can be indexed and searched alongside everything else. This will use the same consistent naming convention, so users can apply the same searches across various data types. While the above is often more than sufficient for many reviews, there are instances where emojis are of particular importance or present unique challenges and require additional specialized support. We can discuss a few such possibilities here, starting with fielded emojis. While the ability to index and search data greatly improves the ability to navigate through the data, there are ways to provide even more functionality. Fielded data refers to data that is structured in a relational way, such that it provides more sophisticated query abilities. To understand this, consider an analogy to another type of metadata, such as a recipient's field. True, such a field could be treated as a plain text field, which could be indexed and searched effectively. However, that would not be taking full advantage of the information presented. It would be more accurate to describe the data contained within as a comma-delimited list of values, which relate to their host documents in meaningful ways. Modern review platforms can take advantage of this structure, greatly expanding our ability to filter and visualize the data. For example, for messages from a given sender, we may want to see a list of associated recipients, ordered by frequency. In relativity, this is known as a pivot table or chart, and it allows us to gain further insight into the data and enable dynamic filtering to drill down into specific items of interest. Indeed, we can achieve the same result by providing the emoji data as a separate multi-object field. As a result, we can get a high-level view of commonly used emojis, filtering by individuals or by conversations between specific individuals. Alternatively, we can start by browsing through all emojis used across the entire dataset, focusing in on those that are potentially important and then breaking those numbers out by individuals who most use said emoji. The options for slicing and dicing the data are endless and can be combined and visualized in powerful ways. So far, we have covered the additional features and functionality that communication intelligence provides. However, equally important is dealing with data that does not conform to expectations. Earlier, we noted that emojis, strictly defined, are based on Unicode identifiers. This is true, but as with anything in e-discovery, we can expect that there will sometimes be exceptions. Unfortunately, we do not live in a perfect world, and not all communication platforms or collections will play nicely. Indeed, the provided data contained a few such instances. In particular, several of the emails contained emojis not as Unicode characters, but as external links embedded as images within the email itself. However, even in such cases, all is not necessarily lost. Despite being non-standard, situations like this do nevertheless tend to follow certain patterns, and that was the case here. A quick evaluation of the text of the data showed that the links in question followed a similar structure, and most crucially, the destination addresses are coded as alphanumeric values that in fact correspond to Unicode identifiers. Of course, this by itself would not necessarily be very helpful when dealing with a large number of documents. However, this is where communication intelligence's loosely coupled and highly flexible processing platform shines. Because the internal emoji database is not static, it allows for additional entries and parsing logic to be applied on top of existing Unicode IDs when searching text for emojis. Thus, we were able to add custom logic to identify the Unicode values and link them to their corresponding entry in the dictionary. As a result, we can provide accurate emoji information, delivered both as an overlay for indexing and as fielded emojis if desired. And these will be consistent with the emojis across other documents. Indeed, the same flexible design that allows us to customize the inputs of the emoji dictionary also allows us to customize its outputs. For example, at any level of specificity, we could pull down different versions of the Unicode database, allowing us to vary the rendering of emojis for chat data based on the underlying technology. If needed, we could compare how the same emojis may have been rendered on different users' devices or perform a custom display for a given export or production. Indeed, case law has seen instances where this has been relevant, with at least 2 major cases hinging on how an emoji was displayed on one device versus another. Of course, it is highly specific use case and many users will not need such levels of customization, but the point is that the tool's design allow for these types of possibilities. Ability to identify emojis within the text of the document opens up many possibilities for analytics and machine learning. It ensures that relevant features of the text will not be ignored by the indexer when composing concept clustering or sentiment analysis. Ability to form concepts over emojis themselves, based on surrounding concepts, could shed light on secret meanings or unusual usage of emojis that may be serving as coded language. Directional networks, typically used to link interaction between parties, could be utilized to link parties to specific emojis, potentially revealing relationships based on patterns of interaction. We reject a one-size-fits-all approach, whether taking advantage of the easy and efficient out-of-the-box solutions or exploring the deeply customized solutions for niche cases. The tool is designed to fit your requirements. Expect the unexpected. The only constant in this area is inconsistency. We don't fight that and design our systems to be adaptable and consistent. Experience and feedback help us grow and develop at the pace needed to keep up with a rapidly changing world. Thank you for letting us give you an overview of TCDI's Communication Intelligence Tool. Have a great day.